All right, this video is going to cover a few true and false questions from section P3, which is functions and their graphs. Right, so these are going to be the last 4 questions in the section that go over some true and false, just because they can be a little tricky to navigate. So we're going to start with, it's technically number 101, right, the first question up here. And it says, if f of a equals f of b, then a equals b. And if you think about it, right, I think you'll see that any even-powered function, we're going to have issues with this statement. So let's just create a function here. Let's say we have f of x equals, we'll pick a basic parent function here, something like x squared, right, an even-powered function. Well, if we do f of a and f of b, let's say a equals 3 and b would be negative 3, right? Because we know with even functions, the negatives and the positives will act the same. So if I take f of 3, well, that would give me 3 squared. F of negative 3 will give me negative 3 squared. Well, 3 squared is 9, and negative 3 squared is 9. Right, so this meets the criteria here. Our f of a does equal f of b, right? F of 3 was the same as f of negative 3. So what this true and false statement says is if this is true, then a must equal b, right? Which we can clearly see, right? Even though f of 3 equals f of negative 3, 3 does not equal negative 3. Therefore, this first one is going to be false, and we have this counterexample to prove it. All right. The second true and false question we have is if f is a function, then f of a of x equals a of f of x. Same idea, right? If we can think of a time that this doesn't work, right, a counterexample, and we can prove it false. So let's stick with the same function. We'll stick with x squared. So f of x equals x squared. And let's say we were going to put in, because we used 3 last time, we'll say let's evaluate the function at 3x. So f of 3x, if I put a 3x in for x, then I'm going to get 3x quantity squared. Well, 3 squared is 9, x squared. So f of 3x equals 9x squared. Now, with what this is saying is, if I take this a value, the 3 in our case, and move it to the outside, we should get the same thing. So let's try 3 of f of x, which would be 3 times the function f of x, which is x squared, which equals 3x squared. So f of a of x equals a of f of x. That would mean in our case that 9x squared equals 3x squared. And I think we'll all agree that that is not true, right? So this is not true as well, which means this is another false statement, and we have this counterexample to prove it. All right, we're on a roll with the false here. So let's look at the third one. The graph of a function of x cannot have symmetry to the x-axis. So we have our axes here, right? This is our x and our y, and they're saying if the graph of a function x, so if it's a function, it cannot have x-axis symmetry. Well, there is this one example here. If we have, let's think of our constant function. Let's think of a constant function, namely f of x equals 0. F of x equals 0 is a horizontal line, right? Because it'd be like y equals, so a horizontal line at 0. So that would be this line right here. Right, if it has x-axis symmetry, right, remember x-axis symmetry, I can look here. If I put, let's test another one here. So this would also have x-axis symmetry. And we would say, like, if this is the point 1, 1, then this would have to be the point 1, negative 1, right? Well, in this case, if you flip this y equals 0, f of x equals 0, over the x-axis, it's going to be the same exact line. So this would prove this false as well. And our counterexample would be f of x equals 0. Right? This is not a function because it would not pass the vertical line test, although it's symmetric to the x-axis. An example where that isn't true, or over here, this passes the vertical line test. This function passes the vertical line test, and it's symmetrical to the x-axis. Right? I believe that's the only case where that is true, that constant line f of x equals 0. So we have another false, 3 false in a row. Let's look at the last one. So the last one says, if the domain of a function consists of a single number, then its range must also consist of only one number. So if the domain, let's say, domain has a single number, we'll just call it a, in it, right? Then our range would be whatever the function is at a. So it would also be one number. So this one appears true to me. We can also think about this graphically, right? If the domain has one number, so let's say the domain is 1, the function also only can have one value, because if it has multiple values, then it's not going to pass this vertical line test, right? So if it doesn't pass the vertical line test, then it's not going to be a function. So the domain of a function, if the domain is only one value, then the range also can only be one value. Otherwise, as you can see here, it would not pass this vertical line test. So that's our true and false questions for section P3. Right, we had 3 false and 1 true. Thank you for watching, and if you like the video, make sure you like and subscribe, and we'll see you for the next one.